Solving equations with radicals. When an equation has a radical involved, try to get the radical on one side by itself with everything else on the other side of the equation. Then raise both sides of the equation to the power corresponding to the index of the radical. So radicals are root, right? The index, like square root, the index is 2. Cube root, the index is 3. So if you have the cube root of something, you cube both sides, square root, square. All right? So sometimes there is more than one term containing a radical. As a general rule, you will need to raise both sides to a power for each unique radical within your equation. This video will focus mainly on raising both sides to a power once, but there may be a couple of examples at the end where we have to do it more than once. Anytime you raise both sides to a power, you must check your answer. All right? That's not negotiable. You got to check it. So here, the square root of 20 minus 8x equals x. Here is our radical, right? Here's our radical. And it's already on a side by itself, which is nice. We don't have to move things around. So, but if you have a radical, you treat it like it's x or y or z or m or w or whatever, and you get it by itself. You solve for it. Add, subtract stuff, divide stuff, whatever you have to do. Get it by itself. And then, now we're going to take this, and I don't like to mess with the original here. I'm going to rewrite it. 20 minus 8x, because we have to go back and check it in the original. So I'm going to square that side equals, put this side in parentheses and square it as well. We didn't have to have the parentheses around the x right there in that scenario. But again, I'm squaring both sides. Whatever I do to one side, I do to the other. So I'm just putting it in parentheses, squaring it. So then what is the square root of something squared? Well, it's just the something. Equals over here x squared. So if you square the square root, the radical goes away, and you end up with 20 minus 8x on the left, and on the right side, x squared is, you guessed it, x squared. Now, this, we go into how we solve these things, whether it be by factoring or some other method, quadratic formula, or whatnot, some method that you have there. So what I'm going to do is I'm going to keep this positive, since it's positive, and I'm going to change colors too, because I did the square both sides part already, which is the crux of this technique. I'm going to take these things and move them to this side. So I'm going to add 8x to both sides. I'm also going to subtract 20 from both sides so that cancels over here and gives me 0 equals. And then on this side, are any of these like terms? No. So just put them in descending order. X squared plus 8x minus 20. So I'll mention different ways to do this. I always try to factor first. I know people don't like factoring, but you need to know how to factor, and I have great videos on factoring. Go look those up if you need help with that. But factor first, because that's going to be your most efficient method to solve if it works. All right? It's much less efficient to use the quadratic formula when something factors or some other method. So here, this is 3 terms. There's a 1 in the front, so this is the list method. All right, so 0 equals, and then I'm going to put my parentheses here. So let's see, I need the factors of 20 that subtract to give me 8. And I'm not worried about plus or minus 8. I'll take care of that in a minute. So 1 and 20, 2 and 10. And if you go, oh, there it is, 2 and 10, you can stop. And I'm going to keep going just for the habit of listing all my factors out, 4 and 5. So the ones that subtract to give me 8 are 2 and 10. Now, the first half of the parentheses has to be x, because these things have to give me x squared. All right? And then the second half has to be the 2 and the 10 to give me the 20. So 2, and it doesn't matter if you put the 10 first or the 2 first. What matters is if you get plus 2 or minus 2 correct, and plus 10 or minus 10 correct. So minus 20, this tells me that these two signs here are different. All right? So in my mind, I'm saying different, but when I read it out loud, I go, oh, the bigger number gets this one. And I say bigger because they're different. So the bigger number gets the plus. Which one's bigger, 2 or 10? 10's bigger, it gets a plus, 2 gets a minus. Okay? 2 gets a minus, so because they're different. So now I have it factored. X minus 2 equals 0, x plus 10 equals 0. And then I move into in my solving by factoring, right? Once we have it factored, we set each factor equal to 0. And then once we do that, we solve each one of them, right? So here we're going to add 2 to both sides. And we get 2 equals x. And then over here we subtract 10 from both sides. And we get negative 10 equals x. So then my two answers are x equals 2 or x equals negative 10. Okay? Those are my two answers. But I can't just take those two answers because I told you, what's the last statement on the page before? Let's look back. Anytime you raise both sides to a power, you must what? Check your answer. So we must check both these. So let's check x equals 2. So what we're going to do is we're going to take this and plug it in the original right here, okay? Always in the original. So this is going to be the square root of 20 minus 8 times 2 equals 2. I'm going to put parentheses around it because I'm plugging it in, but you don't have to do it on that side. It's just x. All right, so let's go through here and let's just simplify the left-hand side. Square root of 20 minus 16, that's the square root of 4. What's the square root of 4? 2. Over here, do I need the parentheses around the 2? No, so it's just 2. And guess what? That checks out. So we know right now, if I had an answer box down here, and if I don't, I'm going to box my answer, but if I had an answer box, x equals 2 is there. What I don't know is do I put comma negative 10 or not? All right, that's what I got to figure out. Do I add negative 10 to my answers? Because when you do this, many of you that know this say, well, just one works and one doesn't work. Well, many times one works and one doesn't work. However, there are examples of these where both answers work and where neither answer works. Okay? So you can't just assume, oh, this one worked, the next one doesn't, or this one doesn't work, the next one does. You can't just assume that. Okay? So here, check this one. So the square root of 20 minus 8 times negative 10 equals negative 10. So the square root of, and some of you can see what's going on here, but anyway, we're going to go ahead and do this, plus negative times negative is positive, so 20 plus 80, square root of 100. What is the square root of 100? The square root of 100 is only 10. The square root is a function, meaning you get one answer out. The square root of 100 is just 10. If you're trying to do some kind of plus or minus thing, you're using something different. The square root of a number is positive. It's called the principal root. All right? So square root of 100 is 10, and then over here, negative 10 is just what we get. So is 10 equal to negative 10? No. So that one is garbage. We throw it away, right? So the only answer here is x equals 2. The only answer here is x equals 2, but you have to check it in the original to see that. So let's look at another one. The square root of 6x plus 1 equals x minus 1 is the radical by itself. It sure is. So then guess what I'm going to do? I'm going to take the square root of 6x plus 1 and I'm going to square it equals, I'm going to take x minus 1 and square it. So what is the square root of 6x plus 1 squared? It is 6x plus 1. Now on the right hand side, don't tell me it's x squared minus 1 because that's not right. You got to be careful. You got to see, I'm going to come over here, and this one is going to take a few steps. But since the left side only took one step, I'm going to use a little thought cloud to figure out my steps over here. And the other thing is, I don't do the formula that comes with this. I do this every time and teach my students too, because all my students are really good at foiling. Much better at foiling, I should say, than the formula. I never taught the formula. I don't teach the formula. I did, I guess, early in my career. And then I quit teaching the formula. Because once you multiply a bunch of these together, you begin to see the formula, and the formula makes sense. Until then, you don't just need to blindly try to use a formula. And again, I say that from experience, 30 years of tutoring and teaching, 10 of tutoring and 22 of teaching. Okay? So, I mean, you gotta just work them. And then you see the patterns, and then everything makes more sense. All right, so here, first, outer, inner, last. It's going to be x squared minus x plus 1. Okay? And 2 minus x's don't cancel. It's x squared minus 2x plus 1. That's that final answer there. So then guess what? I'm going to take this and just put here x squared minus 2x plus 1. And that way, I went over to the side in a thought cloud and did my 2 or 3 steps and didn't have to, write down 6x plus 1 a few more times or whatever. However you want to do it's fine. You could have, followed this all the way down and done 4 or 5 steps, or 2 or 3, 4 or 5 steps there, but how many ever it takes. All right. So I chose, because the left-hand side was just one step, to go out to the right in a thought cloud and figure out what the right-hand side was. Okay. There's nothing. I like my thought clouds. You don't have to like them. You don't have to do them. All right. On this one, it's not necessary. It's just something I do. So now we want to get this thing equal to 0, right? That's how we solve things with x squared. So we're going to subtract 6x. Wait a minute, let's see, I've done that. Let me change colors like I did last time. So now we're going to do this, subtract 6x. That's a like term. I wrote that underneath that on purpose. Those are like terms. Those things cancel and get 0 equals x squared. There's no like term with that. But here, these are like terms. That's minus 8x, is it not? And then here, those cancel. They're gone. Plus 1 minus 1 gone. So x squared minus 8x equals 0. Or 0 equals that, same thing. So now, 0 equals its two terms. When I have two terms, it's either GCF, difference of squares, or SOPs. There's nothing else that's going to be for factoring. So then what do we have? We have a GCF of x, right? And what's left? X minus 8. And then it's factored. There's nothing else you can do with that. And then, And then I take each one of those and set them equal to 0, right? This one's already solved, so I don't need to solve it. This one over here, though, I'm going to add 8 to both sides. And 8 equals x. So here are my two solutions. So I'm going to come up here, and I'm going to say x equals 0 or x equals 8. And what do I need to do? I must check them, okay? So we're going to check them. So we're going to go back again to the original to check it, okay? So we're going to say the square root of 6 times 0 plus 1. All right, and then equals 0 plus 1, right? I'm sorry, not plus 1, minus 1. So this is going to be the square root. What is 6 times 0? 0 plus 1, and then keep going square root of 1, and that's equal to 1. And over here, 0 minus 1, if they don't have the parentheses, which we don't need there, but again, I'm filling something in, so that's what I do just to show it, and we have plenty of steps here. 1 does not equal negative 1, so 0 does not work. So far, if I had an answer box down here, I got nothing written in it. So either my answer is going to be x equals 8, or I don't have an answer. I don't have a solution. Because 0 did not work. 0, I solved and got 0, but when I checked it, 0 is garbage. Had to throw it away. So now let's check 8. Let's check 8. So we have the square root of 6 times 8 plus 1. And notice I'm going to extend my radical there so it's over the 1 to make sure that I know it's under there. Equals 8 minus 1. So let's work on the left-hand side first. What is 6 times 8? 48 plus 1. And what is 48 plus 1? 49. That's still under the radical. I haven't taken the square root yet. So then what's the square root of 49? 7. Over here, this is 8 minus 1, which is 7. And 7 equals 7. So that is my answer. X equals 8. And I didn't have comma 0 or anything because I didn't have another answer. So let me reiterate, whenever you solve and you raise both sides to a power, how many ever answers you get, you have to check all of them. And any of them could work or not work. And any combination of them could work or not work. They could all work and all not work, no matter how many answers you find. So you have to check them.
All right, so let's look at this problem here. We have x minus the square root of x plus 11 equals 1. So again, we have a radical in our equation. What do we want to do? We want to isolate the radical if we can. So we have one radical here. We definitely want to isolate it. There's different ways you can do this. You can add the radical, move the 1. I'm going to move the x. I'm going to subtract the x because that's just one step in my radicals then isolated. So the x's cancel, and I get negative square root of x plus 11 equals 1 minus x. And once I get to this point, now my radical is isolated by itself. You say, well, can I divide by negative 1 or something? Yeah, you can do that, but you're creating more work for yourself because when you square both sides, what's a negative squared? It's a positive, right? So that negative is not going to bother you. So I'm going to take this and square this side. And it looks bad. Let me fix that real quick. Square this side and then square this side. So if I square this side, right, the radical squared is going to be x plus 11 equals. And remember, a negative squared is still just negative. And then I'm going to have a little thought cloud here and say, okay, what is 1 minus x squared? That's 1 minus x times what? 1 minus x. I encourage you to write this down and FOIL it because everybody knows how to FOIL. right? If we try to remember the formula, sometimes we forget the middle term or the 2, whatever, and all this other stuff. So I don't do the formula for this. I just write it down twice and for this. I'm going to do first, outer, inner, last. So I get 1 minus x minus another x and then plus x squared. Those two terms together go together. So 1 minus 2x plus x squared. And if you want to turn it around and put x squared first, it doesn't matter. When I get ready to solve the whole thing, I'll do that. But right here, just 1 minus 2x plus x squared. And now I have an equation that has no what in it? No radicals. That's what I wanted. That was my goal. So I'm going to subtract x from both sides. I'm going to subtract 11 from both sides. And I get this all cancels. I get 0 equals negative 10 minus 3x plus x squared. And what do I not like about this? If I'm trying to solve that, and in this case, x squared, I'm going to try to factor it, right? That's what I'm going to try to do first. So in this case, I want to put it in descending order just because that's what I'm used to seeing. So let's say 0 equals, and we're going to say x squared minus 3x, not squared, minus 3x minus 10. And now we are ready to factor this. So let's go in here and say we're going to say 0 equals, and we have x and x. If it factors, it's going to be x and x, right? And we want the factors of 10. We got 1 and 10 or 2 and 5. So do either one of those sets of factors subtract to give me 3? Well, yes, 5 minus 2 is 3, right? So let's put a 2 and a 5 in here. And it doesn't matter if you put the 5 first or the 2 first. What matters is that you put the plus 2 or the minus 2, the plus 5 or the minus 5 in there properly. So now we say the signs are different. The bigger number, this is bigger number, gets a negative. Which one's bigger? Well, 5 is bigger. The bigger factor gets a negative. So then 2 gets a what? A plus, because they're different. The only way to get a negative 10 is to have a plus and a minus there, right? So now that we have that, then we say, okay, let's solve this. Let's go through and solve this. We're going to say 0 equals x plus 2 or 0 equals x minus 5. And you can put the equals 0 on the other side. It's the same thing. We're going to subtract 2 here. We get negative 2 equals x. And for this one, we're going to add 5. So we're going to add 5 to both sides here. And this cancels. We get 5 equals x. Now, do we just accept both those answers? No. No, we don't just accept both those answers. All right, we don't just accept both those answers. So what we need to do is we need to check. We always have to check our answers. When you raise both sides to a power, when you start with that radical, you've always got to check your answers. So let's check our answers. And we're going to check x equals negative 2, and we're going to check x equals 5. Okay? We're going to have two of these things here. And we're going to check them in the original equation. This up here at the very top. Not something I've already rearranged, back at the very beginning. So I'm going to plug in negative 2 minus the square root of negative 2 plus 11. And that's going to equal what? 1, or should equal 1. So let me put a little divider in here so I can have that for checking both sides and not run them all together. So let's go ahead and finish this one out. Negative 2 minus the square root of, and this parenthesis here is unnecessary, but I did it just because I'm plugging in a value, right? So I want to emphasize I'm plugging in that negative 2. What is negative 2 plus 11? Well, that's 9, and that equals 1. All right, negative 2 minus the square root of 9 is 3. It's not plus or minus 3. The square root of 9 is only 3. All right, and then negative 2 minus 3 is negative 5 equals 1. And does that work out? No, this is garbage here. Nope, that doesn't work, right? So we have to throw out negative 2. X equals negative 2 does not work. Now here's another question. Do I just assume now that 5 works? No. Remember, I can't just assume. I have to check both answers because there are occasions in math where you're checking answers and all of them work, even if it's more than 2, or none of them work, or, it may be that 1 works and 1 doesn't, or if you're checking 3, it may be that 2 works and 1 doesn't, but it may not be. 2 might not work, 1 might. So you always have to check every answer because just because 1 doesn't work doesn't mean another one does work, or vice versa. So let's plug in 5. Now we're going to say 5 minus the square root of 5 plus 11 equals 1. So 5 minus, and again, the parentheses are unnecessary for this one, but again, I'm showing that I'm plugging in the 5. What is 5 plus 11? That's going to be the square root of 16, and the square root of 16 is just what? 4. What is 5 minus 4? 1. Aha. That works. Bingo. So now my answer is what? My answer is simply x equals 5. All right? My answer is simply x equals 5.
All right, so let's keep looking at these. The square root of 8x plus 17 equals x plus 4. It's already got the radical on the side by itself, so guess what? We're going to immediately square both sides. We're going to say 8x plus 17 in the radical squared equals x plus 4 squared. Right off the bat. So square root squared is 8x plus 17. And over here, again, I'm going to do my little thought cloud so I can figure out what it is. It's going to be x plus 4 times what? X plus 4. Again, in my 30 plus years of tutoring and teaching, I don't know if I've met any students who are better at formulas than they are at foiling. It's not very many, like less than I can count on one hand. All right? So just foil it. Just square it, write it down twice and foil it. First, outer, inner, last. X times x is x squared. Then you get x times 4 is plus 4x. 4 times x is plus 4x. And 4 times 4 is plus 16. And you put your two plus 4x's together, you get x squared plus 8x plus 16. So we get x squared plus 8x plus 16. And then, once we finish that, now we're ready to get it equal to 0 and factor it or solve it some way. Which, if it doesn't factor, we'll have to change their method, right? Subtract 8x and subtract 17. Again, if they have like terms, put them underneath them. So 0 equals x squared. That cancels. There's no x's left and then minus 1. So I don't like that space there, so I'm just going to rewrite it like this. And you could put it together here. You don't have to space it out. I was just leaving my columns lined up there. So 0 equals x squared minus 1. So then let's factor it. And we get 0 equals, it's two terms, there's no GCF, and it's the difference of squares, right? You should immediately recognize that. So 1 here, one's plus, one's minus. And then we do what? We take each one of those and set them equal to 0. So let's see, we're going to add 1 to both sides. You get 1 equals x. That looks like an H. See if I can fix that. 1 equals x. And then over here, I could have done this one first, but anyway. That cancels. Negative 1 equals x. So we have, over here, we go x equals negative 1 or x equals 1. And what do we have to do? We have to check it. We have to check it. So we get square root of 8 times negative 1 plus 17 equals negative 1 plus 4. So 8 times negative 1, that's negative 8 plus 17. But wait a minute, it's still in a radical. What is negative 8 plus 17? That is 9. Square root of 9 is 3. Over here, this is negative 1 plus 4, which is 3. And guess what? That checks out. So if I have an answer box down here, I know already x equals negative 1. So what I don't know is, do I put a plus or minus 1? Or put a 1 in there with it? Or do I just leave it negative 1? So let's find out. We're going to check 1. Square root of, let me kind of separate this a little bit. 8 times 1 plus 17 equals 1 plus 4. So this is 8 plus 17 under radical, which is 25. And what is the square root of 25? 5. And over here, this is 1 plus 4, which is, wait a minute, 5. That checks out too. So x equals negative 1, comma 1, or we have what? X equals plus or minus 1. That's how I would write it. But it's not wrong to write it the other way. Just make sure if you're in somebody's class, if they require you to put plus or minus, then you make sure when you get to that answer you do that. And you might think it's ridiculous or whatever, and you don't understand or don't understand, but again, that's a detail. So if your math teacher asks you to do something that you think is crazy, it's a detail, and you have to remember that when you get to that point for that detail. You may have a job one day that requires something similar. It may not be plus or minus, but when you get to the end of your report, you may need to put something there. Or when you get to the end of your project, you need to, don't forget to do this, or your presentation or whatnot. Okay? So whether you understand why or not, it may not always be there, but the fact that it may need to be done, okay, is what you need to be able to think about as you go through the process. Oh boy, look at this. Square root of x minus 5 minus the square root of x minus 8 equals 3. I can't put those two radicals together. They are unique radicals. So if you remember, I said a statement in there. For each unique radical you have to square or raise both sides to a power that many times. We're going to have to actually square both sides because these are square roots twice here for this to work. We need the radicals to be on one of the radicals to be on a side by itself. So let's do that. I'm going to add, just because I don't want it to be negative, I'm going to add the square root of x minus 8 to both sides, okay? When I do that, that cancels. I get the square root of x minus 5 equals 3 plus the square root of x minus 8. Oops, I'm keep wanting to write something else there. X minus 8. Now when I get to that point, and I shouldn't have, I'm going to fix this. I didn't want to mark through my original equation. So let me come over here and say the square root of x minus 5 minus the square root of x minus 8 equals 3. I'm going to add the square root of x minus 8 and add the square root of x minus 8. Plus I'm giving myself more room here, which is good. Square root of x minus 5 equals 3 plus the square root of x minus 8. Now I'm ready to take both sides, and I'm going to go ahead and change colors here because this one's just a little bit more intense. So I'm going to square this side and square this side. Square root of this squared is x minus 5. All right? Equals. This side, if I come over here in my little thought cloud, this is going to be a little bit bigger, more intense thought cloud. So let me come over here and do this. I may need two boards for this one. We'll see. 3 plus the square root of x minus 8 times 3 plus the square root of x minus 8. Right? That's what I'm squaring here, right? Maybe you get this if you know the formula. Again, I just write it down twice and FOIL it. First, 3 times 3 is what? 9. 3 times this is going to be plus 3 square roots of x minus 8, right? And then here, plus 3 square roots of x minus 8. And then here, plus x minus 8. Right? The square root times the square root, it goes away, just x minus 8. So, let's continue to simplify this. 9 plus, put those together, it's going to be 6 square roots of x minus 8. And this is really plus x minus 8, so I can put the minus 8 and the 9 together. That's going to be 1 plus, or if you want to, put it in a descending order, however you want to do this. X plus 1, right? The x, and then the 9 minus 8 is 1, plus 6 square roots of x minus 8. So that's finally simplified. So I'm going to put here x plus 1 plus 6 times the square root of x minus 8. So I got rid of one radical, but now I still have the square root of x minus 8 on the right side. So I'm going to now subtract x and 1 from both sides. Those cancel, and over here that cancels. I get negative 6 equals 6 times the square root of x minus 8. If these things are not conducive to dividing, and you know, if that was 5 and 6 and you divided and got 5/6, I would leave the 6 on the right side right now. But here, it's very, very nice. If I divide both sides by 6, that becomes 1 over 1, that becomes 1, right? All these things become 1. So if that was 12, it still become 2. That's okay. So negative 1 equals the square root of x minus 8. So guess what I have to do now? Square both sides. Square both sides. So then negative 1 squared is 1 equals x minus 8. And then I'm going to add 8 to both sides. And I get what? 9 equals x. I get 9 equals x. I get only one answer to check here. X equals 9. Because some of my x's canceled out. All right. So check this. Now wait a minute. Let me think about this for a second. I squared both sides twice. Okay, so let's go back and check this. We're going to have the square root of 9 minus 5 minus the square root of 9 minus 8 equals 3. So this 9 minus 5. We don't need the parentheses there. 9 minus 5 is 4. So square root of 4 minus the square root of 1. That's going to be 2 minus 1 equals 3. 1 equals 3. And wait a minute. That's nonsense. And we didn't get any other answer. We didn't get any other answer, so no solution. Or as one of my students used to say, no solid. So no solution here. All we got was 9. We checked 9. It doesn't work. All right? Just because we square both sides twice doesn't mean it's not going to work. It just means here the only answer we got didn't work. Okay? So 2x minus 3 under the square root minus x minus 2 under the square root equals 1. This is the same kind of deal that we just had. So let's go ahead and let me do the same thing and hope I have enough room. Okay, 2x minus 3 minus the square root of x minus 2 equals 1. And we're going to add the square root of x minus 2 to both sides. And there's no magic to that step. It's a negative one, so I'm moving it over. So minus 3 equals 1 plus the square root of x minus 2. We're going to square both sides. If we square this side, 2x minus 3 equals, on this side we have our our big thought cloud where we say 1 plus the square root of x minus 2 times 1 plus the square root of x minus 2. All right? So first is 1 times 1, then 1 times that's plus the square root of x minus 2. Here that's another plus the square root of x minus 2. And then here, what is the square root of x minus 2 times the square root of x minus 2? It's x minus 2. And since it's just a plus out here, I don't have to put the parentheses. But if you want to for emphasis, you can. You can put it out there. So this is going to be 1 plus, you got 2 of these, right? 2 square roots of x minus 2 plus x minus 2. So then if I put it in descending order, I'm going to put the x first. And then I'm going to put this and this together. So I get x minus 1 plus 2 times the square root of x minus 2. So that's what I put here, x minus 1 plus 2 square root of x minus 2. So you see what I did? Rather than doing 1, 2, 3, 4 steps across here, 2, 3, 4, and writing this down over here, I just filled in my thought cloud and brought it over here, right? So didn't have to write this down 4 or 5 more times. So now let's try to get this thing equal to 0. So we can, not equal to 0, equal to this radical over here. So we're going to subtract x from both sides. We're going to add 1 to both sides. And that cancels, and we get x minus 2 equals 2 times the square root of x minus 2. So because this time, if I divide by 2, then I get over 2 right here, and I don't want to do that. Okay? So it doesn't matter if you square this, you just square the number and the radical. So that's what I'm going to do here. I'm going to square this side, and I'm going to square this side. So on the right side, 2 squared is 4, and the square root of x minus 2 squared is x minus 2. So it's just 4 times x minus 2. On this side, you got that thing squared. So again, I'm going to have another thought cloud over here. Have another thought cloud of x minus 2 times x minus 2. But this thought cloud is for this over here. Okay? So then that's going to be what? I don't know why I put a parentheses there. It's going to be first, it's going to be x squared, x times x, then x times that's negative 2x, right? And then that's going to be another negative 2x, and that's going to be plus 4. And then put those negative 2x's together, x squared minus 4x plus 4. And then bring that over here, we get x squared minus 4x plus 4. And I guess really I could have gone ahead and distributed that in a thought cloud somewhere, but let's just write down the next step. Equals 4x minus 8, right? Distribute. So just feels like a time for a new color here. We're going to subtract 4x because x squared is positive on the left side. We're going to add 8. These things cancel. We get 0. And we get x squared minus 8x plus 12. This is 3 terms, 1 in the front, so this is list method. So I'm going to go ahead and factor it down here since I think I might run out of space. Factors of 12. 1 and 12. 1 and 12. 2 and 6, or what? I know we just found it. All right. The ones that add to give me 8, right? I don't care that that's negative 8. 12 that add to give me 8. 2 and 6. Okay? So put in here 6, I didn't put my x there, 6 and 2. The signs are both positive. I know they're different right there, but the only way to get a plus 12 is to multiply two positives or two negatives. Well, to get the negative 8x, these two have to be negative. But when you multiply them, they give you the plus 12. So now we're ready to take this. We're ready to take this up here and solve it. X minus 6 equals 0 or x minus 2 equals 0. So we're going to add 6 to both sides. We get x equals 6. And over here we're going to add 2 to both sides and get x equals 2. So those are my two solutions. X equals 6, x equals 2 with an OR. And what do I have to do? Check. I got to check them. Got to check them. So then if I'm going to check them in the original right here. In the original. So square root of 2 times 6 minus 3 minus the square root of 6 minus 2 equals 1. So that's this first one. We're going to divide it up here. In fact, I'm going to divide it up with a different color here. I'm going to divide this up. All right. So then this is going to be the square root of, that's going to be 12 minus 3 minus, if I go ahead and put that together, there's a square root of 4 equals. So the square root of 12 minus 3 is 9 minus, I already know what the square root of 4 is. It's 2. Square root of 9 is 3 minus 2 is 1. So this is 1, and guess what? That checks out. So if I come down here, I got my, let me use some more colors. Why not? Let's have some fun with some colors. All right. So then one of my answers I already know is x equals 6. And then let's go back and let's try this next one. Square root of 2 times 2 minus 3 minus the square root of 2 minus 2 equals 1. Square root of 4 minus 3 minus the square root, that's going to be 0. So the square root of 1 minus, square root of 0 is 0. Square root of 1 is 1. 1 minus 0. What is 1 minus 0? 1. Oh my goodness, that one checks out too. So x equals 6 and 2. X equals, or 2. X equals 6 or x equals 2. All right, so we found two answers, and this time both of them work. Now, I don't want you to think that if you square it both sides that they either both work or both don't work. It's just the way the examples that I chose worked out. So you could have gotten one that worked and one that didn't, or you could have gotten both that did or both that didn't on any of these problems. All right, I hope this helps as you solve with radicals involved.